Hello. Okay. Cool. I think that looks louder. Is that better? Just waiting for it to catch up. Okay, that sounds better. So, okay. Just test out all my hotkeys. Cool. Okay. So we're picking up. So basically, the idea behind this live stream is to show you how to calculate distance using postcodes and Python. And this is part of me building a recommender algorithm for a house recommendation data set that I've created. And the purpose of the whole series is to learn about building a basic recommender. So I've got here synthetic house data, recommendation data that I've created, and you can find this on my Kaggle, which I've linked. And then I've got some open postcode data, which I think is from the UK government. And so I've read all this in. Unfortunately, the house data has some like unnamed zero or has like an index that shouldn't be in there, so I had to drop that. Once I've dropped it, the house data looks like this. This is just me looking at one of the fields, like the house keywords, which is supposed to be looking like data extracted by a large language model. And because this comes as a string, not as a list, I've turned it into a list. Then I've loaded the postcode dataset. The columns don't come in automatically, so I've set them, and this is just again from the UK government website, I believe, and this is what this looks like. And I only really care about, for distance calculations, we only really care about latitude and longitude. And I want the postcode with no space because there's just typically fewer errors when you have the postcode with no space. I've set that to the index, and the reason I did that is because it makes it a lot easier to index into the data frame and treat it like a dictionary almost. So yeah, I've got 30,000 houses. Yeah, and the idea is to extract information about the features that I created in my synthetic data set and then use them all together to create an algorithm that ranks them for a particular user, for a given user's input. Now, I had already started on the postcode distance function, but I found, unfortunately, that some of my data was a bit unclean, it was a bit dirty, and I had, so if I just, oh, it's too late now, but basically there were some values that had this instead of the latitude or longitude. So I've just used this housedata.query and said, okay, if latitude is not equal to this, and I have to use these double backslashes, because backslash is normally used for special characters like \m for new line, and so if you have to backslash a backslash for it to be a real backslash, and because this is 2 backslashes, I've had to double backslash to get rid of it. But anyway, once I got rid of these, which couldn't be turned into a float, you can see the house data can be turned into a float type. So actually, whilst I'm here, I might just say house data.lock all rows, and if it's latitude or longitude, as type float. Oops. Just been using a different keyboard. Okay. Yeah. So what I'm doing here is I'm just saying I want the latitude and longitude to be of type float now, whereas before I guess they were object because they had this string in them. And now if I check, oh, they're still object. Huh? Did I not run this? Okay. Well, it worked that time, despite the warning. Okay, let's do it here as well then. Okay. Cool. Cool. Okay. Yeah, so this is just some of the information I expect to get, and the one we're interested in is postcode. And we've got preferred house type, min price, max price, whatever, like stuff you might expect to see on Rightmove, basically. So yeah, so we've got this function here, get distance by postcode. And the idea is it reads in a postcode from the user postcode, takes a latitude and a longitude, gets the postcode's latitude and the postcode's longitude that has been provided. So the user provides a postcode, and then we find out what the longitude and latitude of that postcode are, and then we use that to calculate the distance. Okay, so you can see that there, PR8 1SE and 53.108 blah blah blah. This is just some UK postcode, and that gets translated to 183.129 kilometers, which is a bit weird because I'm not really sure I want it to come out like that. Print distance.distance.kilometers. All right, okay. So perhaps I want to do distance.distance.km. Nice, that's better. So rather than do that, let's just say it's going to return this instead. Okay. Cool. Pretty sure this is just testing something. So I'll just delete that. Okay. So now I'm going to apply this function to the whole data set using .apply and lambda and a lambda function that applies get distance by postcode. And it takes don't know why is it printing that stuff? Let's do that for a sec. There we go. When you print stuff out as well, it just takes a little bit longer. Okay. That was a good few seconds. So what we're trying to do here is we're trying to think like if this was a real world scenario, what would be an acceptable length of time to wait? Let's just see. So if you don't know, you can do this. Pretty sure it's this. Let me just quickly check. Come on. Cumulative, yep. Nice. And then we'll see what it was that takes it so long. So the cool thing about data science is it's a really interesting combination of like mathematics and communication. This is the communication part, and the and computing. And one of the big things in computing is that you shouldn't ever try and optimize code until you profile it. All right, until it fails. You shouldn't try and optimize code. Let's see if that works. Optimize code before you profile it. And the idea there being it's very difficult for you as a human to reason about what's taking so long. We don't typically know. So it could be, I mean, it could be this distance calculation, but what if it's not the distance calculation? What if it's that these postcodes, like this replace is taking a long time, or the .lock is taking a long time, or something like that. Key error cumulative. How is that an error? As we're here, let's just try this. Let's try getting rid of that. Just see if that works. Maybe this will work then. That did. string 1 module. Get distance by postcode. Distance.py. Gen inverse geodesic, blah blah blah. Okay. Well, so it's hard to tell from this what it actually is. It looks like it's, I mean, indexing is part of it, but it doesn't really seem like it's the big problem. It's the distance calculation that's the problem. Distance in it. Is there a way of doing it? So let's go to consensus. Let's go to ChatGPT, our trusty friend. So vectorizing is a method you can use in computing where you take data that basically has a similar meaning but is different data, so you know, different latitude, longitude points, and you say, okay, I want to, because I know these bits of data are very similar, I know I can treat them in very similar ways, and that allows you to do computation faster because you can, without thinking, use a single instruction in a computer to process many data elements at the same time. And this is like one of the things that GPUs do, where you have a similar set of computations and you put them through the GPU. Each tiny core does one of those computations, but it's basically the same computation on different pieces of data. Session not yield results on picturizing. Yeah, not particularly helpful. So, I wonder if let's just start another one. Oh no, I don't want it to be consensus. Okay. I mean, that could be right. You sometimes get a lot more than you bargain for with ChatGPT, and if you don't use it, I would really strongly recommend using it. It's an awesome tool just for figuring things out. And when you're really, really stuck, you can use the Stack Exchange sites. Okay. The great circle distance between 2 points, which is the difference over the Earth's surface. Convert from degrees to radians. Okay. Difference in latitude over 2. Let's see if we can get it to do it for us. Okay. Okay. This is potentially something I should have looked up beforehand. Let's see if ChatGPT managed to work its magic. Oh, it hasn't done it. No, for God's sake. Cool. All right, let's see. Sometimes this just works right out the box. Interestingly, I saw something the other day which said that people, it used to be the case that developers, coders who were older were more efficient, which is why they got paid more money. But now it turns out they're actually becoming less efficient because they're less likely to use AI tools. Which is amusing. Cool. Delon. So it's sine squared theta over 2. Okay. Interesting. Okay. Nice. Let's see then. Let's see what this gives me. So that's the distance, is it? $5,354 miles. What was this estimating? 5,570. So is that woefully wrong? That's the problem with some of this stuff, is that I always find Wikipedia is terrible at explaining things. It's like it's quite good if you've already seen it before, but let's go back to ChatGPT. What was it saying? Got that right at least. Let's see. Okay, so it is the Haversime formula. I mean, it's possible. Let's just see if what is it? Distance dot distance. Something's going wrong here. I think it's this. It's to do with this. Don't think these coordinates are right. Which would make more sense. Don't know why I would expect it to know that. What is it for LA? South, fine. It wasn't super far away. Well, maybe it was. So it's Naughty Elephant Squirt Water west, so it's to the left. Is that positive or negative? Here we go, that's better. Right. you. Oh. Okay, that's LA. What's New York? If I just get rid of these. What's this doing? Codes 1 and codes 2. Codes 1. Yeah, I mean, that is slightly confusing. Okay. I personally prefer NumPy notation. No, I don't like this either. Okay. So basically what I'm going to do here is I'm just going to improve this function. Yeah. I'm basically just going to improve this function and make it work in the way that I thought it was supposed to work, which is I want to provide two sets of coordinates and calculate the distance between them, or I want to provide one set of coordinates. So basically, if the shape is 1, 2, then I want to multiply that array down and then match it to the length of the other coordinates and calculate the distance between all the different ones. Hope that makes sense. So yeah, coords mp.nd array. I mean, you could even extend it and say, well, if I give you one set of coordinates, if the number of coordinates match, say coords 1 doesn't match coords 2, then I treat it as if I want to calculate the distance between each set of coordinates in coords 1 and every set of coordinates in coords 2, but it's whatever. So I don't want to do that. I just want to... Don't know if that works as well. Why don't I just do... See if this works. So the difference in the latitude and the longitude. Huh? What's going on? Oh, there we go. It's just, they don't have to do that. It just handle it automatically, won't it? Will it? No, possibly not. Whatever. I could put an else in here, but you don't actually have to, so I'm not going to. I prefer it, some people don't. Because basically what you can do is you can say if this, and you know that if you follow this through, okay, well, if it raises, then everything's going to stop anyway, so it doesn't matter what happens afterwards. But if it doesn't raise, then you're just going to carry on, and it's basically an else anyway. So yeah, I'm not going to put an else in case you're wondering why not. I think you can tile. Let's test. One of the good things about having a Jupyter notebook. Okay. Okay. So That's the one. Nice. So we'll say coords1 equals mp.tile coords1 and 2.shape1. Nice. Okay, so this bit of code, as you can see from this, basically using numpy.tile, we're giving it an array, and then we give it the dimensions along which to repeat, which you can sort of see here, although I don't know, I don't think this is a very good example. A2, oh, this is better. Yeah, this is better. So this is the one we're looking at. And we want to tile the coordinates, I think, because we need to do that for the latitude and longitude part calculations. So let's just have a size. Just have a size, isn't it? No? For sign form, which perhaps the first equation, consider when understanding how to calculate distances on a sphere. Follow an equation where phi is that? Latitude lambda? Or is it gamma? Yeah, it's lambda. Is that one phi? What's the other one? Psi, that's it. Yeah, so phi, pretty sure. Phi is latitude, lambda is longitude, and r is Earth's mean radius. So we translate the above formula to include latitude and longitude coordinates. Reject. Okay. Phi b. So it's saying the angle around there, the versine. Okay. Phi a over 2. Oh, hey. This is where it's ripped it from. Probably. Looks like ChatGPT's basically ripped this off. Back to this then. The haversine function, something you probably don't know, computes half a versine of the angle theta, or the squares of half chord of the angle on a unit circle sphere. Oh. Thank you very much. So helpful. This is it. Easy, right? It's one of the most frustrating things about maths is that if you're not willing to sort of learn all the little things like, well, what actually is the have a sign and what actually is the ver sign, a lot of mathematical language is very, very dense. There's a lot of very dense concepts, so it's just annoying to try and understand it when you just want to calculate something now. It's like, oh yeah, like this sentence, the have a sign function computes half a versine of the angle theta, or the squares of half chord of the angle on a unit circle sphere. What arsehole wrote that? Central angle have a sign. Okay. How do you undo? How does one undo a have a sign? Oh. Gonna have to walk back what I said now as I come on here. Look at this. Why are they saying it's arc sign though? Okay, fine. So it's saying I want. Is that tan squared? Okay, so we know that at least that this part forms part of it, so let's do that part. Okay. D-lat, D-long. Arctan 2. The quadrant. Element-wise arctangent of x1 divided by 2. Choose that. I guess we'll see if it works. So if I say I'm going to go with this for LA. No, I'll leave that. And I'll also do let's get LA and NYC. Hey, New York, hey. Cool. Doesn't like it. Too many indices for array. Array is one dimensional, but two are indexed. Yep. So again, I can't actually remember the best way to do this, so I'm just going to check. Oh, I wonder if I do p.tar11, oops. Does that work? Oh, it does. Okay, I'll do that then. So basically what this is doing is saying, okay, well, if you've given me a 1D array, make it a 2D one by tiling it 1, 1. So now that should name lat one is not defined a K. Oh, right, okay. So maybe I want to say, or maybe I don't actually. It's just duplication. Okay, see if that works. Ah, there we go. So it reckons it's 4,000 kilometers between LA and NYC. That doesn't sound right. $3,934. Let's just check it against something else that's like a... Sometimes you can call things like this golden models. Signed decimal degrees without compass directions where negative indicates west or south. Oh, that's nice. Let's try this. Okay. So there's a possibility then that maybe that's the GPS coordinates I'm getting for Los Angeles aren't the ones. Wow, 4,000 kilometers though. From New York to LA. That's crazy. Huh. Why was he giving me 122 before then? Okay, let's try that now. Aha. Hell yeah. Oh, sweet. There we go. So, it looks good so far. Now we have to check it against, see if it works for a larger data set. So, let's try it on every... Let's try it on all the latitude and longitude coordinates in the data set. House data set is not defined. What have I called it? House data or something. Yeah. Nice. Okay. So I'm pulling this out as a NumPy array now. So let's just see. If I say that this now is coords 2, I get rid of that. What now? Oh! Look at that! Well, that's a lot faster. So, yeah, I think that's a nice place to conclude. So basically, I've vectorized the distance calculation using the haversine formula, which we have checked, and it works, I think, with the help of ChatGPT. And because of that, now I should be able to use this haversine vectorized formula to do a very quick calculation of all the distances between the user and the postcode that each house is at. And because now this takes, well, I actually don't know how long it takes, but it doesn't take a very long time. So I've wiped out this coords thing, have I? Let's just see if I print distances dot shape, what do I get? Okay, yeah, so 29,000 calculations all in one go. Although in fairness, I don't actually know if this works. Yeah, that's a point. Actually, maybe I should just... Let's just check it works first. So... let's go Brooklyn. Okay, and do that. Closing parenthesis. Nice. So we get 3935 and 394. Oh shit, it's Brooklyn near you, not New York. Yeah, that's basically what I got. Okay, let's try some. Well, I mean that kind of does show it works, but let's try something more interesting. Where's Detroit? Okay, that's similar sort of place. Boston. Similar place. Las Vegas. Yeah, cool. That's different enough. Let's try that. DC, Brooklyn, and Las Vegas. 368, okay. .361, I think. Whatever. It's reasonably close. Yeah, they're saying 368. I don't know. It's close enough, I think. Yeah. Yeah, so we've got a really fast vectorized function now. And in fact, you know what? I might just quickly... Yeah. So this is a good way of describing it. It's the process of transforming a scalar operation acting on an individual data element. So say you might want to add 1 and 2. You have the operation add acting on 2 data elements into a single instruction multiple data operation where say I've got like 300 data elements and I want to add up each other one. So it's like I'm going to add the first one and the second one, the third one and the fourth one, the fifth one and the sixth one, etc., etc. I would line them up next to each other and just perform that one add on them all the way down. And that makes it a lot faster. And so, because you can take advantage of parallel hardware. So you can do the operations basically at the same time. And that's why this is much faster. And also NumPy is just faster because it's written in C++. So it gives you access to like bytecode, which can run on a machine more efficiently, whereas Python has to go through various stages to get stuff done, goes through like a virtual machine and stuff. So yeah, we've created the have a sign formula. I'll probably produce an article on this, seeing as that is quite interesting and it doesn't seem very well explained, so I'll write an article on it explaining it better. And yeah, that's it basically. The distances we can calculate very quickly now, and that's the first bit of feature extraction. I have actually extracted them because I have done this, but I'll tidy it up in the next live stream or maybe before, and then we'll get started on the next part of the feature extraction, the house type, shall we say. Okay, see you in the next one. Bye.